Hello everyone and welcome to Diana webinar. My name is Maz and today I'm going to give you a live demo about the modeling tools and features that we have in our latest release, Diana 10.3, regarding modeling pile elements. Today we are going to model a 3D bridge pier based on 12 piles that basically models rest on 3 soil layers. So based on different categories, we're going to talk about the parameters that we have for these 3 soil layers. The model is subjected to asymmetry loading. So on the bearing part on the left side, you have loading more than basically on the right side. We have our piles which are embedded partly in the concrete. So this is basically with a high grip. We're gonna show you how to model that, and additional part of that penetrate goes into the 2 layers of the soil and rest on the basically solid layer. We're going to give you a technique for those who want to consider the pile drive test as a kind of a load displacement diagram as a continuous overall response with the frictional and pile tip, and also some tips regarding those who want to work or compare our procedure with some procedures that they used to do with the PY curve. So that means they have some individual parameters per soil layer. The input parameters are basically listed here. This document will be available on our page, so you can freely download as a tutorial based on the standard format that we have, similar to other tutorials. We have elastic material model for the pile and the bridge pier, because our focus here is to illustrate the simulation and modeling procedure for pile elements in Diana, in the latest release of Diana. We use a nonlinear material model for Morclom for our soil layers. We have 3 layers of soil with basically K-node procedure, the ratio of the horizontal and vertical stresses, some information regarding our pile with the corresponding diameter. It's circular. Our pile, the grip part, the high grip part, which is the in interaction with the concrete, you can see it has a very high stiffness parameters with ultimate shear force relatively high. Also, the part that goes into the soil, we have other reduced parameters and some sort of a failure, ultimate shear force failure. So these are just illustrative parameters just to show you how to set up, where to find, how to navigate your modeling process. And I'm sure you have other parameters and you are responsible for your input based on your own readings. For the pile tip, the part that rests in the, say, the rock base, we have a pile tip element with the corresponding stiffness and ultimate resistance force about 500 kilonewton. Our pile has a circular, say, section with the reference cross section of this value that you see here. And we're going to use this value to highlight the elephant foot or the effective area for the pile tip. So this is again another nice feature in Diana that enables you to mimic this effective area when your pile tip is resting on the soil. So let's get it started. What I'm going to do, we open Diana. We make a new project, click OK. Our reference units, this is very important. So when you enter into the environment, always adjust your unit based on the parameters that you have. If you remember, we were dealing with the kilonewton and meter. So at the bottom right corner, my length is meter. I change my force to kilonewton. So perfect. Our units are set. The next thing that we're going to do, we're going to define a reference surface for our ground. For that purpose, I click on the surface option that we have here. we have many methods to create based on the rectangular face, based on the coordinate, relative coordinates. That means 1 point with respect to previous, not with respect to the global coordinate. So I show 2 methods in this particular case. Let's start with the rectangle. So we start at 0, 0, the reference corner at 0, 0, and the diagonal position or the counter part of that is 120. If you say fit on the screen, so this is my reference face. What I'm gonna do next, I'm gonna select this face and extrude it in, say, 3 different layers to make sure that I'm forming my foundation, or say the ground. For that purpose, I go for extrude. I select my reference face. So the reference direction is in the Z, so you can see either you can drag and drop based on the interactive coordinates that you see here, or directly input here the value that you want to be extruded. So the first layer is -6. I click apply. So this is my first solid segment or first soil layer. Here you can just simply change the name. You can call it layer 1. So what I am going to do, I'm going to extract the bottom face here like this. Maybe I select that. Extract, so you can see additional guide surface has been selected. So now I'm going to go for extrude, this time based on the new surface. I select it. Again, I'm extruding downwards in the Z direction, this time to form my second soil layer. I define it -5, apply. I repeat the same procedure. I change my filter. Here you can see the filters are based on solid, face, line, and vertex. I change the face. I select the reference face here. Right click, extract. You can see the new sheet has been generated. Again, I go for extrude. I select this third sheet, and again, this time I'm going for my third layer. So click apply, close. So here it was layer 1. I changed that to layer 2, layer 3. So far everything is smooth, perfect. So we made our model based on the 3 layers of soil. Then I'm going to make a block positioning of the foundation of my bridge pier in the middle of the soil. For that purpose, I activate creating a block in the model, and based on the reference coordinates that earlier I already calculated, I define some data for X, Y, Z, and click on create. So you can see this block is generated here. You can change your view from top, so it is in the middle of the model. This is just to make sure that I have enough boundary or distance from the activation of my loading and say the construction zone, to make sure that I don't have any bounding effect during the analysis. The next step that I'm going to do, I'm going to make the structural part of the upper part of the bridge pier. So for that purpose, I'm going to create basically polygon sheet, but now I'm changing my workflow or the method to coordinates. So this is a very interesting method, because you can select this. So you can copy paste this data from Excel if you have. So that's how I did it here. I click on create. So you see here a sheet has been generated as a kind of cross section of my bridge pier. What I'm going to do, I'm going to extrude it in the global Y direction. So here at the bottom left corner, you can see the green one is my global Y direction. This is the X, and the blue one is Z. So I select extrude, I select this sheet in the Y direction. I extrude it as 2.3. I click apply, close. So now you see my model is ready in terms of the solid. So to make it a little bit optimize my model, what I'm going to do, you can see one block of solid. So here you can see the sign here representing solid as a kind of cube. I have two blocks, one for foundation, one for pier. I'm going to merge them to make sure that I have one operating block. So I can select the upper one as my master, this one as my tool, unite, apply, and here you can see it's only one object. I can change that and put the name of pier. So far, all the solid parts of my model, as easy as what you saw, been created. The next step is to create our piles. For that purpose, I go to create line, and what I'm going to do, I'm going to define coordinates of the upper part, which is the part that is embedded inside the concrete, and the lower part is the lowest part of the pile that goes into the soil. So I have some data that I'm going to use them as my reference. So this is the upper part. Then I go for the lower one. So you can see here it tells what's the total length of this pile is 11 meters. I click on create. So here the line is generated, but you say I'm not seeing where is that. So I am going to hide my solid, also my pier. So this is the pile that I generated. If you hold your mouse over the object, you can see some sort of a shadow of the object that we are hiding it. So you can see the position of embedded part of the pile and the position that goes inside the soil. So what we are going to do, we are going to generate 12 piles by using array copy rather than inputting the coordinates of each pile and generating them. So let's do that in a kind of smart way. I go for array copy. I select the first one, and in the negative or minus y direction, I'm going to copy that 2 times. So you can see 2 times it's been generated. Apply. So now I have 3 piles, then I'm going to array copy in the X direction. So that means if I have here, I'm going to form additional piles in the X direction. Again, my array copy is there. I'm going to select the existing piles, this time in the X direction. So minus, that's the first group. You can apply. So you can see there is a apply and close. This is an action box. So if it's always on till you close it. So this helps you if you want to do repetitive procedure. The environment or the dialog box is available for you for the fast and efficient modeling part. So I'm going to select everything, all the 6 piles that I have, but this time I'm going to copy the whole group in another distance. So this way all my piles are formed. So if I show you my pier, so you can see part of that is embedded, maybe 10% of the length is embedded, the additional part is penetrating into the soil. So what I'm going to do now, the point is I want to tell to the program that my pile has two segments. The one part is the part which is embedded in the concrete, an additional part that goes directly into the soil. So this implies, as I mentioned at the beginning, if you have some sort of different characteristics, PY curves and characteristics of the soil, and you want to assign it along the pile, you need to proceed with the same procedure that I'm going to highlight now. We are going to imprint two bodies. So I'm going to basically select this. And if I click on apply and hide my pier, you're going to see there is a kind of a imprint of the position of intersecting my bridge pier, the foundation part, the block part, with the, say, existing piles. This way, we see the characteristics of the shaft here is way higher in terms of the grip than the part that goes into the soil. What I'm going to do next, now you see I have 12 piles or lines in the model. I'm going to break them into two groups, one in the small group on the upper part or part 1 and then part 2. For that purpose, I'm going to select all these groups, right click. In the modify, I'm going to say to the program, break all my lines with the position of the imprinted location. So you can see any pile that I have are automatically broken or divided based on the imprint or the position of the layer or the object that you want to assign different characters. So here in this particular case is that basically concrete body. Just before I forget, at the material level, just for ease of understanding, I'm going to change the angle to degree because we are going to define some sort of soil parameters. Might be it's more acquainted with the degree rather than radian. So we are good. Now we are going through our new development and the pile set formulation that we have in the model. Before that, maybe we can highlight something here. You can import always some material properties from the previous analysis that you have done. So for that purpose, you can see there is import option. So if you click here, you can always navigate where you want to go. So from any model, you can easily recall your existing soil models or concrete models or any other material model. So you don't need to always input those parameters on and on and on. So what we are going to do now, I'm going to import the soil models. And we are going to define the parameters associated to pile. If I highlight, so might be a little bit with delay, so I try to basically give some time because some people notice that yeah, it's getting updated a little bit slow, but we are there. So what I mentioned, literally, you can import the material properties based on the corresponding dialog box. So to ease off or to speed up the modeling, I imported the material property associated to the soil layers. And if you, for instance, click on the soil layer at the material level, click on edit, you can see the corresponding parameters that we had. For instance, for the bottom one, with the certain parameters, with the characteristics of the monochrome and the corresponding part associated to the, say, K-node procedure. So please let me know if you have a kind of late update on the screen. Please let me know, then I try to see how we can improve it. You can use the chat box if you don't see now the dialog box associated to the material model. Perfect. So as I mentioned, what we are going to do here now, we are going to create pile sets, and we define two different pile sets. One pile set on the top, which the piles which are embedded in the concrete, and another group of the piles which are in the soil. So we have this create pile set option. We click here. In terms of the name, I call it pile in concrete. Here you can see we have two options. Either is axial pile behavior that you want to consider, or bending pile behavior. I click on bending, and for material, I click on adding material, pile in concrete. I click OK. So I do this procedure together to make sure that we follow the steps together and see if there is anything that you can identify which is much more efficient and in your benefit in terms of the modeling. So we start with the characteristics, if your pile has a pile tip or no, what are the Rayleigh parameters if you want to consider with the dynamic analysis, and later we're going to assign the geometry attribute and properties like a cross section and also the reference axis of the pile and cross section of the pile. So first we start with the material, the generic material for the pile. For that purpose, we have this concrete. We consider it as a linear elastic with the corresponding mass density. Then we are going for stiffness values. So these stiffness values are our nominal stiffness for the basically pile. One is for normal, one is for shear stiffness. So the normal one, it's quite high because we say the pile has no permission to be separated, and with the shear also is quite high in terms of the grip. The failure that we are going to consider here is basically ultimate shear failure. So you can see there are different characteristics you can consider here for the failure mechanism. So in this particular case, I'm going based on the load displacement and excuse me, a high value that we have. So these are all, I cannot say fictitious, but they're all high values in order to show that we don't have any slipping occurring between concrete and pile. So this is the part associated to the material. I'm going to the geometry part. I call it pile. So this helps you if your model is casted or changed in some sort of topology in depth or in shape. You can always have this flexibility in Dana, and that's basically the advantage that we offer in Dana, and that's flexibility but applied solution. So I click OK. You define what type of cross section that you have. I say circular. In terms of the diameter, I define 0.7. Reference axis that we have, I define it here, and also the value for the cross section here is not necessarily, but to be consistent, I add that value here in the model. You say create, so keep an eye in the geometry shape. If I say piling concrete create, and you can see a new set for the pile element with the name of piling concrete has been generated here. So this is very nice operation because now I am selecting all the part ones that I have. So you can do that either from the this geometry window, or you can do that from the working environment. So you can see all the part ones, that means the upper ones are selected. I'm going to drag and drop them into my element set. So you can see, as simple as that, there are series of piles that are assigned to that specific group. What am I going to do? I'm going to repeat the same procedure, this time for the piles which are inside the soil. So again, I create a new pile set. I call it pile in soil. Type is bending. I create a new material property for that, pile in soil. I have a pile tip in the model. So you can see this is basically this part. So therefore I'm going to highlight the pile tip as well. So in terms of the geometry, it's the same cross section. I select the pile so you can see the corresponding parameters are set here. In terms of the material properties are a little bit different. For the concrete is the same. So what I'm going to do is the same procedure as input value for the physical properties for the Young modulus, for the mass density as well. Then I'm going for the normal stiffness. So here for the pile in the soil, what we are going to do, going to define our normal stiffness. So now you can see compared to the previous one, it's a little bit smaller. So then you allow some sort of a movement. Your shear, you can see, is much more weaker now. The failure of the pile, again, I say based on the load displacement diagram. This is the conventional one that you can get it from the site to have a pile test or pile drive test. So you can get that diagram and always use and drive these parameters right away from your graph. And I define the value of 1000 for my ultimate shear force. Then in terms of the failure for my pile tip, I'm going to define two characteristics, two stiffness parameters for my normal and the lateral one. So here we have for normal one is 6, and for my shear one is E3. The failure that I have is based on the ultimate resistance force. I click here. So basically it's a kind of a snapping point. Just we want to highlight in this tutorial some bulbs in the post-processing for the piles which are failing from the tip. So that's why I select this. This is for illustration, 500 kilonewton. I say create, and you can see pile in soil set, 0 entities have been generated. Once again, I'm going to select all the piles that I have here, and I drag and drop them here into the group 2. So as simple as that, I have my model, solid, generated based on some Boolean operation, face, extrude, extrusion, multi-array copy, and my full model is set. So the properties and attributes for my piles have been assigned. Now I'm going to assign the properties to the soil layers and the bridge pier. For that purpose, I'm going to create assign properties. So I select the bridge pier. In terms of the material class, is basically structural solid. Based on the material property that I imported, is a linear elastic. I assigned. Then second one is a topsoil layer. Update. The middle one is a mid-soil layer. Update. And the last one is basically bottom soil layer. I update. So this way all the material properties have been assigned to the model. Another important things or nice feature that you can use it is basically changing the color. So if you have some sort of a model with different characteristics, for better understanding and discussing with your clients or with your other colleagues, you can always define some sort of a different color in order to make it more elaborative and representative for your model. So material properties have been assigned. Then we are going to assign the loads and boundary conditions. For loads, I'm going to assign the sulfate first. It's a generic, so here when we are dealing with the sulfate, program automatically takes your mass density and multiplies by the gravity acceleration and generates the weight. Be aware, always your input at the material level is mass density. I click on create. So if you go on the section for the load, you can see my sulfate is generated. I'm going to create my bearing pressure on the bearing position. So I call it left pressure. I define a new set name. So you can define one set name, as you see, and different name of the loads assigned to that set. So you can group them or you can define individually. In this particular case, I define the bearing loads in one set. In terms of the selection, I select the left one. So you can see it's nicely selected. I define minus 3000. In the global Z or normal, these are all the options that are available here. You can click on create so you can see the representation of that here is available. I'm going to do the same, this time right pressure, acting under the same load set. So if I expand, the left one is already assigned. I'm going to generate the right one because in the analysis, I'm going to activate these two loads acting simultaneously. So I'm going to select this phase and this value is 2000. So this way I'm generating some sort of a asymmetry load. So here you can see additional load set also been defined. The next thing that I'm going to do here is assigning the boundary conditions. So you can see the arrows, the direction of the loads. You can hide, visualize them. The next thing that I'm going to do is positioning or defining supports. For that purpose, I click here. I say boundary conditions in the boxing model for the soil in the X direction, assign to the global boundaries set. So this is the same concept as I explained to load. You can control and manage your boundary conditions as well. I'm going to select all these faces on this side and this side, and I tell to the program, constrain them in the X direction. So you can see X, Y, Z, or rotation in X, in Y, in Z. So I click on create so you can see the boundary conditions in the X directions are generated. If I expand that, you can see them. I'm going to repeat the same, this time in the frontiers on the Y direction. So I say BC Y. I select the corresponding parts. Make sure that you unselect and select the right DOF. I click on create so you can see additional Y direction is generated in the same group. Now I'm going to create the last one, which is a vertical support. I'm going to select the lower part and then in the Z direction under the same boundary set, create. So you can see I have one boundary set that when I activate, all these three directions get constrained or boxing my model at once. Everything's set. Now we are going for seeding process. For seeding, I'm going to select, say maybe to the shape. I select my concrete part first. You can change to the division or element size. You can always click on preview. There are some arrows on the model. These arrows are basically the direction of each edge. So if you want to linear grading, you know where is the start, where is the end point of these edges. So I select this with the 1 meter. It's elastic. This is not really big issue. I click on apply. The other process that I want to do, I hide my boundary conditions for better visualization. I'm changing my selection of the seeds to the edge, and I select the edge in depth. So I'm going to select the edges in depth in the model. And what I'm going to do, I'm going to define 4 divisions. So here you can see in depth, all edges are covering 4 divisions. I click on apply. And the last step, I'm going to make sure that my 4 boundaries, the position of the boundary of my model with respect to the bridge pier, are getting a little bit coarser seeds. So again, I select shape, I select these 3 layers, and then maybe I go for this time divisions, 8 divisions, so you can see the position of the seeds. For your note and attention is the priority of the seedings is always edge dominates the surface, surface dominates the shape. So if you assign some seedings over the edge and later you write something over the shape, the parts and the corners which they do carry this attribute at the edge will carry those information. If you don't want, you can always reset those seedings. So I click apply. My model is ready. You can save it and go for meshing it. So you can see the model is nicely meshed. It's a hexadominant mesher. It's perfect engine that we have in the latest implementation. It's enhanced. You can see 2 sets of piles generated here. The pile in the concrete, so you can see them. If I zoom in, you can see there are highlighted. There are embedded in the concrete, and the parts that are embedded in the soil. So you don't need to worry about anything. Program automatically generates them and literally embeds into the mother elements. For this particular case, I'm going to do the phase analysis, and that's because of the initialization process and then activation of the piles and pier and then loading. So I'm going to create a new analysis case based on the phase. In the first phase, only my soil layers are active, basically the in situ condition of the ground. I click close. I add a new structural linear analysis based on the initialization in the model. So what I'm going to do here, I'm going to initialize my soil layers based on the sulfate, because you have this option here to initialize based on the stress tensor, especially when you're dealing with the tectonic pressure or some sort of effective parameters, or just normal K-node procedure. So this is a normal K-node procedure. I click OK. What else you can do here after initialization, it's common that you reset the displacement if you want. You can here add physics, and in the physics you can say suppress my displacement or my displacement and strain. So it's always, they do that with the displacement, but you can keep the stress and strain because that's basically the nonlinear status of your model embedded in all the soil layers. And when we go for excavation or activation of some new elements, you need to come with the new balance. So we reset only displacement because under the sulfate these soil layers will settle down, and then we will have some sort of a new state of the ground for our project. I'm going to add additional phase. This is my next phase, and here I'm going to activate my pier and my piles as well. So everything gets activated at once. This is just for illustration purpose. Indeed, you can activate your piles and then go for the additional phase, activation of the peer. But as I mentioned, this is just for illustration purposes. So I go for transferring the results from my previous analysis here. So this way, I'm going to bring the state of the stresses from the previous analysis into the new phase. And here in the load step, I'm going to tell the program, now consider my pressure acting on the model. So I select the corresponding load set, click OK, and we are ready to run the analysis. So while it's going through the analysis, it's straightforward. I can bring the one that I've already done. So the analysis is already over. We have two phases. Initialization, transferring the results to from first phase to second phase, and activation of the bridge peer, and basically loading. In terms of the results, in the first phase, you can see the bridge peer is not active. That's why you see as a frame. So you only see the layered cake stresses that are in the vertical direction due to the stress initialization. And here you can see at displacement level, everything is 0 because we reset the displacement. In the second phase, you can see the bridge peer is active, the piles are active, there is a overall or average displacement of the 7 millimeter. It's just you can see nicely its position is symmetry. And then in the next phase, you can see if I go for a deform shape, it's when the loading are acting on the bearing parts, you can see how the model is bending on one side. So what I'm going to do here, I'm going to show you the results of the piles. So what we go for pile cross-section forces. If I say NX, you can change that to the diagram and you can nicely see how these results are shown in a diagram form. In terms of the visualization, you can hide your soil layers. So to give you better insight if you want to make some report. What else we had? We had a moment. So you can see the moment, how these piles are kind of bending in the model. And another important result that we had was pile tip. So if I go for pile tip NX, I change that to the contour. So you can see the group of piles which are basically at failure value. So you can see 500 and the others which are kind of in a pooling. So they are in different scale. So this was a quick overview on modeling process, on result interpretation, on the different grouping techniques that we have in Dana with respect to the different pile groups. You can easily use them in your model. The 10.3 is already available on our website and you can download it. If you have any questions, you can always contact us. The tutorial also will be available in our website and also the recorded session as well. Thank you very much and have a very good day.